My dear students, welcome back to our channel. In this video, I will be explaining the B.Ed second semester subject content and pedagogy of physical science education at secondary stage, as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: define pedagogical content knowledge, PCK. Pedagogical content knowledge, PCK. Definition: pedagogical content knowledge, PCK, is the teacher's ability to understand the subject deeply and teach it in a way that students can easily understand. It is not just knowing science, but also knowing how to explain it effectively. Key idea: teachers combine content knowledge, facts, concepts, and theories with pedagogical knowledge, teaching methods and strategies. Example: a science teacher knows Newton's laws of motion, content, but also uses toys, experiments, and simple stories, pedagogy, to make it fun and clear for students. Why it's important: helps teachers simplify complex topics, makes science engaging and practical, supports different learning styles of students. Easy memory trick: PCK is equal to content plus creativity. It's like a cook who not only knows recipes, but also knows how to serve food in a tasty, attractive way so everyone enjoys learning. Next important short question is: to mention any two evaluation techniques used in science teaching. Two evaluation techniques in science teaching. 1. Written tests. Written tests are the most common evaluation method where students answer questions in the form of short answers, essays, or numerical problems. Example: a physics test with problems on motion equations and diagrams. Why useful? Checks students' memory, understanding, and problem-solving skills. 2. Practical performance tests. In practical tests, students perform experiments or demonstrate skills to show their understanding of concepts. Example: in a chemistry practical, students test the pH of different solutions using litmus paper. Why useful? Helps teachers evaluate students' hands-on learning, observation, and application skills. Easy memory trick: think of evaluation like checking a recipe. Written tests is equal to check if students know the recipe. Practical tests is equal to check if students can cook the dish. Both methods together ensure that students understand science theoretically and practically. Next important short question is: 3. What is the importance of enrichment of content knowledge? Importance of enrichment of content knowledge. Enrichment of content knowledge means deepening and updating what a teacher knows about their subject. A teacher must go beyond textbooks to understand science concepts, discoveries, and applications thoroughly. Why it's important? 1. Builds confidence. Teachers with strong content knowledge teach more confidently and handle students' questions easily. 2. Better explanations. Deep knowledge helps teachers explain topics in simple, creative, and practical ways. 3. Connects science to real life. Teachers can relate lessons to daily life or latest technology. 4. Encourages curiosity. Well-informed teachers inspire students to explore more. 5. Keeps teaching updated. Science changes quickly. Teachers must stay current with new discoveries and trends. Example: a teacher who knows advanced applications of solar energy can make lessons on energy sources more exciting and relevant. Easy memory trick: enrichment is equal to upgrade your science toolbox. More tools is equal to better teaching. Next important short question is: 4. Write 2 examples of learning outcomes in physics. Two examples of learning outcomes in physics. Learning outcomes are clear statements of what students should know, understand, or do after learning a topic. They make teaching goal-oriented and help teachers check progress. Example 1. Newton's laws of motion. After studying this topic, students should be able to explain Newton's 3 laws in their own words. Identify and solve simple real-life problems, like why seatbelts are important or how rockets launch. This shows both understanding and application of concepts. Example 2. Electricity and circuits. After completing this lesson, students should be able to draw a simple electric circuit diagram, calculate current, voltage, and resistance using Ohm's law. This outcome ensures students can apply formulas and create real-life connections. Memory tip. Think of learning outcomes as what students take home in their mind: knowledge, skills, and confidence. Next important short question is: 5. List 2 chemistry topics from Class 11 textbooks. 2 chemistry topics from Class 11 textbooks. The Class 11 chemistry syllabus introduces students to both basic concepts and practical applications. Here are 2 important topics. 1. Structure of atom. This topic explains how atoms are built using protons, neutrons, and electrons. Students learn about Bohr's model, quantum numbers, and electronic configuration. For example, understanding why sodium, Na, has 1 electron in its outer shell helps explain its chemical reactivity. This topic forms the base for studying chemical bonding. 2. Chemical bonding and molecular structure. Students learn how atoms join together to form molecules using ionic, covalent, and hydrogen bonds. For example, water, HO, has a bent shape because of the arrangement of electrons. This topic helps students understand the structure and properties of compounds in real life, like why salt, NaCl, is solid but water is liquid. Tip to remember. Think of atoms as building blocks and bonds as glue. They hold everything together. Next, Unit 8. Long questions. First important long question is: explain the steps of pedagogical analysis of science content with examples. Steps of pedagogical analysis of science content. Pedagogical analysis means breaking down a science topic into simple parts so that teachers can plan how to teach it effectively. It helps connect the topic with students' level of understanding and real-life experiences. Steps. 1. Select the topic. Choose a topic from the science textbook. Example: photosynthesis from Class 8 Biology. 2. Content analysis. Break the topic into smaller concepts and facts. Example: photosynthesis has parts like sunlight, chlorophyll, co-intake, O-release, and glucose production. 3. Identify learning objectives. Decide what students should learn: facts, concepts, or skills. Example: students should be able to explain how plants make their food and why sunlight is important. 4. Prerequisite knowledge. Check what students should already know. Example: students must know about plant parts like leaves, stem, and roots. 5. Teaching methods and aids. Plan how to teach using diagrams, experiments, or models. Example: a simple experiment showing oxygen bubbles from pondweed in sunlight makes learning fun. 6. Applications in daily life. Link the topic with real-life situations. Example: farmers grow crops under sunlight. Indoor plants need sunlight to stay healthy. 7. Evaluation and questions. Prepare questions to test understanding. Example: why is sunlight necessary for plants? What is the role of chlorophyll? 8. Remedial measures. Plan activities for slow learners, like using pictures or videos. Why it's important? Pedagogical analysis helps teachers organize lessons, make learning easy, and spark curiosity. It ensures students don't just memorize facts but understand and apply science in life. Tip to remember. Think of it like cutting a big cake into small slices. Each piece is easy to eat or understand. Next important long question is: to analyze the Class 11 Physics syllabus from a pedagogical perspective. Analysis of Class 11 Physics syllabus from a pedagogical perspective. The Class 11 Physics syllabus builds a strong base for higher studies in science and technology. It focuses on conceptual understanding, problem-solving skills, and applications in daily life. Let's analyze it step by step. 1. Content structure. The syllabus is divided into units like physical world and measurement, laws of motion, work, energy, and power, thermodynamics, oscillations and waves. These topics gradually move from simple to complex, helping students understand core scientific principles step by step. 2. Learning objectives. The aim is to make students understand physical concepts and their mathematical representation, develop analytical and problem-solving skills, appreciate the role of physics in technology, example, electricity, communication, energy. 3. Prerequisite knowledge. Students should already know basic science and math concepts from Class X, like force, motion, algebra, and graphs, so they can solve numerical problems easily. 4. Teaching methods. To make lessons interesting, teachers should use diagrams and animations, example, free body diagrams in laws of motion. Experiments and demonstrations, example, pendulum for oscillations. Interactive simulations to visualize abstract concepts like wave motion. 5. Real-life applications. Physics in Class 11 is linked to everyday life. Thermodynamics explains refrigerators, engines, and air conditioners. Waves are used in music, communication, and medical instruments. 6. Evaluation methods. Numerical problem-solving tests to assess understanding. Practical experiments for hands-on skills. Conceptual questions to develop logical thinking. Why pedagogical analysis helps? By breaking down the syllabus this way, teachers can make lessons more interactive and fun. Relate concepts to real life, so students understand their importance. Help students build a strong foundation for Class 12 and competitive exams like G and NET. Easy tip: think of physics as a bridge between math and nature. It explains everything around us, from moving cars to mobile phones. Next important long question is: 3. Discuss the role of experiments and activities in teaching physical science. Role of experiments and activities in teaching physical science. Experiments and activities are the heart of teaching physical science. They help students move from just reading concepts to actually seeing and experiencing them. Physical science deals with real-life phenomena like motion, energy, electricity, and heat. When students perform experiments, they understand these concepts better and develop a scientific way of thinking. 1. Making science practical and real. Experiments turn theoretical ideas into reality. For example, instead of only learning Ohm's law from a book, students can measure current and voltage in a simple circuit. This shows them how electricity works in their homes. 2. Developing scientific skills. Performing activities teaches important skills like observation, Noticing details during an experiment. Measurement using tools like thermometers and voltmeters. Recording and analyzing data. Drawing conclusions, finding patterns or results. These skills are important for future studies and careers in science. 3. Encouraging curiosity and creativity. Activities like building simple models or using household items for experiments make students curious. For example, showing refraction of light using a glass of water can make them ask, why does it bend? Curiosity leads to deeper learning. 4. Better understanding and memory. When students see and do something, they remember it longer. For example, studying Newton's laws is easier if they observe a ball rolling or colliding with another object. 5. Promoting teamwork and confidence. Group experiments teach teamwork, communication, and confidence. Students enjoy working together to solve problems, which builds interest in science. Conclusion. Experiments and activities make science fun, practical, and meaningful. They help students connect classroom lessons with real-life applications, from using magnets in speakers to understanding engines in vehicles. Teachers should encourage low-cost, simple experiments so every student can explore science, even at home. Easy tip. Think of science experiments as learning by doing. You don't just read about rainbows, you create one in the lab. Next important long question is: 4. Explain the importance of identifying concepts and processes in science teaching. Importance of identifying concepts and processes in science teaching. In science teaching, concepts are the key ideas, like force, energy, or atoms, and processes are the methods used to understand or prove those concepts, like experimenting, observing, and measuring. Identifying them clearly helps teachers plan lessons in a structured and effective way. 1. Builds strong understanding. If teachers first identify the concepts in a topic, students can focus on learning the core idea. For example, when teaching electric current, the main concepts are current, voltage, and resistance. Knowing these helps students easily connect new knowledge to what they already know. 2. Helps choose the right teaching method. When teachers know the processes involved, they can choose appropriate teaching strategies. For example, understanding photosynthesis involves observation and experiments, like testing starch in leaves, so hands-on learning works best. 3. Encourages scientific thinking. Science is not just facts but a way of thinking. By identifying processes like hypothesis formation, experimentation, and analysis, students learn to think like scientists rather than just memorize facts. 4. Makes learning systematic and easy. Breaking down topics into concepts, what to learn, and processes, how to learn, makes science teaching organized and stress-free. For example, motion includes concepts, speed, acceleration, and processes, measuring time, plotting graphs. 5. Supports better assessment. Teachers can create tests based on both concepts, theory questions, and processes, practical experiments. This gives a complete picture of a student's understanding. Conclusion. Identifying concepts and processes makes science teaching clear, interesting, and student-friendly. Students learn to apply concepts in daily life, like using pressure in cooking, and understand how scientists discover new things. Easy tip. Think of concepts as the what you are learning, and processes as the how you understand it. Together, they make science meaningful. Next important long question is: 5. Describe the need and methods of enrichment of science content knowledge. Need and methods of enrichment of science content knowledge. Enrichment of science content knowledge means improving and deepening a teacher's understanding of science concepts. Science is always evolving, so teachers need updated knowledge to make lessons interesting, accurate, and practical. Need for enrichment. 1. Keep up with new discoveries. Science changes rapidly, example, new findings in space or medicine. Teachers must stay updated to teach correct and current facts. 2. Build student interest. When teachers use real-life examples like electric vehicles, satellites, or AI, students become curious and enjoy learning. 3. Clarify difficult concepts. Strong content knowledge helps teachers explain complex topics like quantum physics or chemical bonding in simple words. 4. Improve teaching confidence. Teachers with deep knowledge feel more confident and can answer students' questions better. 5. Link science to daily life. Enriched knowledge helps teachers show practical uses, like using thermodynamics to explain refrigerators or engines. Methods for enrichment. 1. Workshops and training. Attending teacher training programs, science fairs, and seminars updates teachers with new techniques and discoveries. 2. Reading and research. Referring to science journals, magazines, and updated textbooks helps teachers stay informed. 3. Digital learning. Using online courses, educational videos, simulations, and apps makes learning fun and keeps knowledge current. 4. Collaboration. Discussing with other teachers and scientists helps share ideas and best practices. 5. Hands-on experiments. Regularly doing experiments in the lab strengthens understanding and improves teaching skills. Conclusion. Science teaching becomes more effective when teachers enrich their knowledge. It makes lessons interesting, practical, and inspiring for students. A well-informed teacher creates curious and confident learners who see science in everyday life. Easy tip. Think of enrichment like charging your phone. Teachers must recharge their science knowledge to teach better every day.